So today I start the solid state. So we know the most things we see around us are the solid state. So in the case of periodic table, we also know that the only 11 elements are found to be in gaseous state at the room temperature and 1 atmospheric pressure. Also we know that only 2 elements are found to be present in the liquid state and remaining all the elements are known to be in the solid state. So we interact with the solid the most in our day-to-day life and our demand for them are diverse. Okay, so what is the demand in for the solid state? So for the building purpose, we want the strong structure that can withstand the earthquake, even the storm. So in the case of crane cable, we need to find to lift the heavy weight without breaking. For the car, we want the lightweight material to improve the fuel efficiency. And in the case of rubber, we want the high stretchability rubber. And for the shoes, we want the maximum grip to the floor. And in the case of a sick material, the we want the minimal electrical resistance. And even if for the hydrophobic we want a desired hydrophobic glass for the car window. So these are the some list, and there is a numerous demand for the solid state. So first of all, we understand the property of the solid. So what is the property of the solid? They have definite volume and the shape. What is that means? So unlike that liquid, which can take the any shape of the container while remaining the constant volume, and for the gases which take both the shapes and the volume of the container, but the solid retain its shapes and the size regardless the container. So also in the case of intermolecular distance, the solid shapes short intermolecular distance. So if the intermolecular distance is small, then the intermolecular force is very long. We know that. These forces, the intermolecular forces, are held together the constituent particle like the atom, ions, and the molecules together. The and the particles are bound to their neighbor and cannot move their position. So they have the fixed position. Also, the solid states are incompressible, while no material is incompressible. So solid states are much less compressible than the liquid and the gases. So if we distinguish between the solid state between uh, from the liquid and the gases, then in terms of intermolecular distance, the solid state very small then compared to the liquid and the gases. In terms of molecular distance forces, the solid states have the highest and strongest intermolecular force than that of the liquid and the gases. For the particle movement, the solid state have the particle in the solid state are fixed in their positions, while in the liquid state the molecule can move and flow, and in the case of gaseous state the molecule can move randomly. So in the case of compressibility, the solid state are less compressible than the liquid and the gases, and in the case of the shape and the volume are also discussed. So so why this property is to be different than the liquid and the gases which are to be studied. So depending upon the three nature, the solid state have the very diverse property than the liquid and the solid gases. So these are the three steps like the nature of the constituent particle and the strength of and or the binding force and the structure. So with the and in these classes we discuss about the binding force and the structure. Okay, so what do we mean by binding force and the thermal force? So binding force is the amount of energy required to bind the constituent particle together, while in the case of thermal energy, the amount of energy required to remove this atom from apart from each other. So binding force and thermal energy is completely reversible to each other. Okay, so if the binding force are greater than the thermal energy, then the substance is the solid state because the particles are held together. And while as the thermal energy increases, the bond also breaking, and allowing the particle move freely and flow, resulting in the solid liquid state. and with the higher in thermal energy, the substance become gases as the particle move randomly. Okay, then we start a study about the structure. So the property of the solid depend upon the structure also. So structure refers to the how the constituent particle like the atom, ions, and the molecules in the solid are arrangement themselves. So their arrangement may be orderly or the disorderly manner. So depending upon the order and the disorder manner, we are classified as the amorphous and the constituent and the crystalline solid. Okay. So what we mean by amorphous? So in the amorphous is the Greek word where A means no and the morphos means shapes. So amorphous means the no shapes and the no order. And while in the crystalline solid, and, uh, and the crystalline solid, the constituent particle are arrangement in regularly and repeated pattern. So due to this they show the different property. So the property may be I discuss about the melting point and the refractive index and the cleavage, which are discussed below. So in the case, I just consider the silicon dioxide as an example because this is present in both in amorphous and the crystalline solid. So also remember that this is the 2D structure, not the 3D. So in the 3D case, each silicon atom is bounded by the 4 oxygen atom, and each oxygen atom is bounded by the 2 silicon atom. So the molecular formula is SiO2. Okay, and these are the some properties which are different melting point due to the different region melt at a different temperature due to the various variation in their surrounding. The energy needed is to break the bond is varies because each region is different from the neighbor region. So the melting point is having the same some range in the case of amorphous solid, and in the case of crystalline solid, it has the sharp melting point because all the region are identical and requires some amount of energy to break the bond, and the entire solid is melt at the fixed temperature because the surrounding of the each region is identical. So thus the energy required is uniform. Okay. Then second topic is the refractive index. So in the case of refractive index in the amorphous solid are isotopic in nature. Means when the light interact with the same ratio of atom regardless the direction. This results the constant refractive index because the interaction with the atom is consistent across different part within the material. Also, in the case of crystalline solid, it is anisotropic. It shows the anisotropic property like because the light interact differently depending upon the direction due to the order arrangement of atom. The refractive index varies with the direction of light because each direction contains the different atom environment lead to varied interaction. So what it means that it is simply means the amorphous solid if the light passes then due to the randomly distribution of silicon and oxygen it can interact with the same ratio of the silicon and oxygen, while in the crystalline solid if the light passes through this line and if the passage through this line then it interact with the oxygen and the silicon in the same structure, but in the case only it is only interact with the silicon. So it show the anisotropy property. So in the last, we study about the cleavage property. So in the amorphous solid, if the cut in a sharp tool, then resulting is the irregular plane. And in the case of crystalline solid, if we cut with the sharp tool, then the resulting surface is the smooth because due to that uh, long range order and the not arranged in the randomly. Okay.